In this video, we're going to have a look at the expected size of the vocabulary in the text. We'll select a specific text to get some experiences with this. And we go into the official Word Maps project. We browse down towards the end and select the State of the Union speeches. We'll take the first one. This is George Washington delivering a speech before Congress in 1790. We need a report to help us, and the report we're going to select is the frequency report. It will give us the number of words, but also show us the frequencies of each individual words in the text. We want to use the English word list as means of comparison, and we also want to include words that aren't really just one word, but actually could be compound expressions, longer expressions consisting of more than one single word. We'll get as much information as possible. Since we're just selecting one text, we take this first option. It will give us up to the first 200,000 tokens in the text. And now we just need to submit, and then we'll get the information in an Excel sheet. I already ran that, so I have it ready here for us. So we'll open this Excel sheet and we'll go to the results. The results here show that, for example, the word which is present in the text 18 times. It is resulting from that number of occurrences. It has become rank number 8, which is a higher rank than we would normally find in average English, where it would occur approximately at position number 230. We can also see the total number of words in the text, and we'll go down towards the end, and we'll see down here that word number 444 is constituents, and it occurs a single time. We can also see here under unknown tokens if there are any tones that weren't recognized by word maps, and as it happens, we have 4 words here, and each of them occur a single time. So it's worth noticing if you're interested in a topic that involves these 4 words, that we will have to add them so the word maps topic model becomes a little bit more complete. It is, however, quite marginal, because the number of words we have here is only 4, and that can be compared with the total number of words. Let me just get that information. We take all of the words here all the way down, or actually we'll take all the numbers, of course, all the numbers here. And we see down here at the bottom of the page that the total number of words, counting words that occur more than once, is 1083. We can now get a look at some characteristics of how these words occur in the material. And let me just draw that into sight here. This first graph is what we call a histogram. And histograms are useful showing how many observations of a certain kind. The histogram is organized in a way where words that occur once, twice, 3 times, or 4 times form the basis for the count in the first column. The next occurrences are from 4 up to 7, from 7 up to 10, and so forth. These are the various possibilities we have, and we see that, of course, there are absolutely most words that occur between 1 and 4 times. We can also see that if we go further down here, we have a lot of words that occur once or twice, quite a few also 3 times, again fewer 4, and only a single word occurs a full 97 times in the text. Let's turn this around, and this next graph here shows words in order of diminished frequency. This picture is also called the long tail. What this means is that you're looking at the most frequent word, this first one here. We of course get in one go, immediately we take care of 97 out of the plus 1000 words. So that's, well, close to maybe 7-8% of all the words in the whole material. So that's a lot to have covered already here. What we should take into consideration is that the first word is really just one of those function words that don't give us too much information about the content of the text. And the same goes for of and to and a, be and in, which may be a little bit more information loaded, but still we don't really know what goes on in the text. That, will, by, from, you, I, with, is, our, your, and so forth. We have to go all the way down to number 27 here, public and government 31, before we get a little bit more tangible information about what is the nature of the text at hand. So the problem is that we may feel that we are very clever by curating the most frequent words, but actually it is often a lot of the less frequent words that give us the important information about what goes on in the text. This could lead us to the next question. How do we actually calculate what what the size of the vocabulary could be expected to be in a text? We have a formula down here that is useful for that purpose, and we're actually going to try it out. So we have the total number of words, and we remember that that was a little bit more than 1000. We can actually write the actual word up here. Let's see, it's 1083, so I'll put it here, 1083. The expected number of words, that's actually what we're looking for. We don't really know that just yet. So let me just order that in this way, yes. And here's our formula. So the expected number of words is 4 times the total number of words, that's the n up here, and we need to put that into the power of 0.67. This formula is based upon experience. At WorkMaps we conducted a lot of investigation into this area, and we came up with this specific version of the formula. So the parameter here, 0.67, is based on the experience from analyzing thousands of texts. We can try it out now, and we have the information we need. So we put into the formula 4 times 1083 to the power of 0.67, and that gives us the result. We would expect in this text to have 432 unique words. And we can of course immediately compare this to how many of the words are actually known, and we know that we know all of them except the 4 here. So we can see that 4 divided by 432, so sorry, 4 divided by, so that's, we'll just have a percentage here, so that's a little bit less than 1%. So we have 0.9% of all the words are not known. If we turn it around, we'll just take this and say 1 minus the missing part here. So actually we have here the positive side of things, that 99.1% of all the words occurring in the material were actually known by WorkMaps beforehand. We also have of course the actual result, and that is a little bit higher. So we know that the expected was 432, but in reality we did come up with 443, and this allows us to calculate a so-called text diversity index. So how relatively diverse is this text compared with an average text? And we can see it's a little bit more diverse than the average text. It's 2.6 index points more diverse. What does this mean? This means that this text can be assumed to be a little bit more information rich. So there's a little bit less cliche, a little bit less repetition. It is a little bit more maybe also difficult to read because there's more information than the average text, but nothing serious. We are very close to the index number 100. So what we have seen here are some various ways of representing the structure of the words in the document. And especially we have completed all this by looking at the formula that can be used to calculate the expected number of words and the text diversity index. That's all for now. Thanks for watching. See you back soon.